Hello, calculus. So today, we aren't going to do anything new. We're just going to practice our integration by parts. We have a couple things that tweak it a little bit. As you know, things always get a little harder. So today we're going to start off with the same. We're going to practice some problems. So you're going to do some little pausing on your own. And then we'll move into a couple new problems. And then you can do your homework. All right, so wrote our formula up at the top just so that we can remember. And our first equation is the integration of x cosine 4x dx. So go ahead and write that down, hit pause on your video, see if you can work through it, and then I'm going to go through it. Okay, so x is algebra, cosine 4x is trig. So remember, when we have our lie 8, algebra comes before trig. So f of x is equal to x, f prime of x is equal to 1, g prime of x is equal to cosine 4x. So g of x, you should get 1/4 of sine 4x. Remember, you had to use u substitution right there. So, f of x and g of x is 1/4 x sine 4x minus the integration of g of x f prime of x, g of x f prime of x. So 1/4 sine 4x dx. So this, and the 1/4 comes down. The integration of this would be a 1/4 times a negative cosine 4x. So our final answer is 1/4 x sine 4x. Oops, sorry. Minus a 1/16, ooh, minus, that'll be a plus, 1/16 cosine 4x plus c. Okay. Great. All right, let's look at number 2. We're going to integrate x cubed ln x dx. All right, go ahead and hit pause. Go ahead and try it. And then when you come back, we'll finish. All right, so this is algebra. This is an ln. So lie 8, the L is going to come first. So f of x is ln x. F prime of x is 1/x. G prime of x is x cubed, and when we integrate that, we get x to the 4th over 4. So, f of x, g of x. So we have x to the 4th over 4, ln x. Now remember, the order of that does not matter. So if you put ln x first, and then x 4 over 4, then that's perfectly fine. So minus g of x, which is this one, times f prime of x, which is this one. So x to the 4th over 4 times 1/x dx, which of course we want to reduce. Okay? If you're reducing that, that's 1/4 x to the 3rd, because x to the 4th over x is going to reduce. You could rewrite the whole problem. I just wrote it right up here, and I'm going to integrate from there. So when I integrate from there, I've got 1/4 x to the 4 over 4. So, pulling my thing down, I get x to the 4th over 4 ln x minus a 1/16 x to the 4th plus c. It's so weird not to ask you questions. I hope you guys are doing well with this stuff. Make sure to send me an email if you do have any questions. Let's go ahead and do number 3. All right, number 3, integration of tan inverse x dx. Okay, so this one's very similar to the one we did yesterday that I think was sine, oh no, but it was cosine inverse. So this one's a tangent inverse. So go ahead and hit pause. See how you do. All right, so this is an inverse trig function. So when we're doing lie 8, and it's the only one there. So f of x is equal to tan inverse x. The derivative of tan inverse x is 1 over 1 plus x squared. Okay, remember that from your inverse trig. G prime of x, remember, is just 1. So g of x is equal to x. So we have f of x is g of x. So x over 1 plus x squared. Oh, nope, sorry. Whoops. F of x, g of x. We have x tan inverse x minus the integration of g of x and f prime of x. So that's our x over 1 plus x squared dx. Okay? So we have a u substitution with this one. U substitution of 1 plus x squared. Du dx is equal to 2x. So I'm actually integrating x over u times du over 2x. Okay? Where the x's will cancel. So it's really 1/2 the integration of 1 over u du. Now remember, the integration of 1 over u is ln. So it is 1/2 ln of u plus c. Now I got to pull down this stuff. So I got a minus sign and an x tan inverse x. So my final answer is x tan inverse x minus 1/2 ln of x, or sorry, 1 plus x squared plus c. All right, so now we're moving on to our new problems. So let us look at number 4. And you may want to put a little star by it because this is where things are going to get a little new. Okay? So we're going to integrate x squared cosine x dx. All right, now we're going to start off just like it starts off on every other problem. So we've got our algebra and we've got our trig. But lie 8, algebra came before the t, or a comes before the t. So your f of x is x squared. Your g prime of x is your cosine x. So f prime of x, the derivative of this is 2x. The integration of cosine is sine. So it's starting off just the same. Okay? So let's go ahead and get started and see what makes it different. So we start off with f of x, g of x. So x squared sine x minus the integration of g of x and f prime of x. So that's going to be 2x sine x. It doesn't matter what order you put them in. Now, do we see that where things go different? The thing that happens here is that this right here is another integration by parts. So we've got to do integration by parts twice in order to finish this problem. So this is algebra, this is trig. So we have a whole new chart. So algebra comes first, 2x. Trig comes second, g prime of x. So you're doing the exact same thing, you just have to do it twice. Derivative of 2x is 2. Integration of sine is a negative cosine. Now, you could probably see, like if this were x cubed, we would have to do integration by parts 3 times. We have the first one, the second one, and then the third time. Essentially, what you need is you need this f prime of x to not have an x in it, to not have to do integration by parts more than 1 time. Okay? We aren't going to have to do integration by parts a million times. Typically, 2 is what we're going to have to do. But just be aware that you could have to do more and more and more. So let's go ahead and do this integration by parts. So we have, for this one, boop, 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 and I'm just going to leave that negative. I'm going to distribute and do all that negative stuff at the end. I'm just worrying about my integration right here. You are going to get a lot of negatives when all this is said and done, but we'll come back and we'll organize all of those. So it's f of x, g of x. So negative 2x cosine x minus the integration of g of x and f prime of x. So negative 2 cosine x. And then we could squeeze in a little dx right there. Okay? All right. So the integration of this right here, the integration of negative 2 cosine x is negative 2 sine x. Okay, so now I have to pull on all these negatives, make sure that I'm keeping everything here. I'm going to pull this down. I've got negative 2 cosine x minus a negative 2 sine x. And if you want to have parentheses things to keep these organized, you're going to have this right here, because you got to pull this down as well. X squared sine x minus. Okay, so now you can kind of organize all of these negative signs. So I'm going to make this negative negative a positive. But then I have to distribute that negative sign. So my final answer is x squared sine x plus 2x cosine x minus 2 sine x plus c. And there's your final answer. All right, moving on to number 5. Number 5, we have the integration of ln of 2x minus 1 dx. This one's a little different as well, but all of it starts off just the same. So we only have L for lie 8. So obviously this is your f of x. Got your f prime of x. G prime of x is equal to just 1. And g of x is equal to x. So this is 1 over u, don't forget the chain rule, times the derivative of u. Now, this is just got a weird thing in it. So let's take a look at what happens. And we do a little magic math here to make this work out for us. So we end up with f of x is g of x. So it's going to be x ln of 2x minus 1 minus the integration of g of x and f prime of x. G of x is x. F prime of x is 2 over 2x plus minus 1. So it's 2x over 2x minus 1 dx. Okay? Now, if you're looking at this, u substitution doesn't really work all that well. Because if you use u substitution for 2x minus 1, the derivative is just 2. You have that extra x lying around. Now, could you do that fancy thing that we did before with the u substitution, solving for x? You could. There's a faster way to deal with this, and it's magical. So let's just take a look at what we could do. If this numerator was 2x minus 1, it would make my life a little bit easier, because 2x minus 1 over 2x minus 1 could just cancel out. So what I'm going to do is I'm going to rewrite it, give myself some more space here. I'm going to rewrite it as 2x minus 1 plus 1, because minus 1 plus 1 is just 0. So it's like I've added 0 over a 2x minus 1. So that what I could do is I could separate this into 2 different fractions. I could have 2x minus 1 over 2x minus 1 plus 1 over 2x minus 1. Okay? So, I'm going to erase something, but let me pull an extra sheet of paper. It'd almost be like I had x plus 3 over 4. I could say that that's x over 4 plus 3 over 4. So it's, oops, you can't even see that. So x plus 3 over 4 equals x over 4 plus 3 over 4. So I'm just separating the fraction. The only difference is I'm separating the fraction with more than one thing in the denominator. Now, why does that help me? Well, that helps me because this is just 1, and this is 1 over 2x minus 1, which I can use substitution for. Okay? So, with this one, when I integrate 1, I just get x. When I integrate this, I have u substitution. Du dx is equal to 2. So I'm actually integrating 1 over u du over 2. So that's going to give me plus 1/2 ln of u. Okay? So now, I pull all this down, I've got my answers here. So I got to pull that down. So I end up with x ln of 2x minus 1. So I've got this minus sign, and this minus sign is going to have to distribute into here. So I've got minus x minus 1/2 ln of 2x minus 1 plus c. Okay. Final answer for that one. Okay, we just have 2 more to do this morning. So I'm going to move this. Going through a lot of paper here. Now, this one we don't need to integrate by parts, but we've never integrated this before. So I wanted us to take a look at this because we're going to need it in our homework. The integration of tan x dx, not by parts. Okay? So we're not going to integrate this by parts, we're just going to integrate this. So in order to integrate tan, because I mean think of all of our integration and our derivatives, we didn't have one that was just tangent. What you have to do is you have to break this up into sine x over cosine x dx. Okay? And you have to use u substitution. So your u is your denominator. Derivative of cosine is negative sine. So you end up with the integration of sine x over u times du over a negative sine x. So your sine x's cancel, and you're integrating negative, put the negative up there, 1 over u du. So it ends up equaling a negative ln u plus c. All right, so keep that in mind. Again, you don't need that for integration by parts, like you don't need to solve it using integration by parts, but you are going to need it in your homework tonight. All right, we have one more example before you can get started with your homework. And that is going to be definite integration by parts. Okay, and what you're going to do with definite integration by parts, meaning that there's going to be numbers at the top and the bottom of your integration, you need to evaluate each part with the numbers. Evaluate each part with the numbers. Okay? All right, so example 4, we've got the integration from 0 to 2 of x e to the 2x dx. this up a little bit. All right, so this is going to get started just like we normally do. We've got our A and our E, so we've got lie 8. So x is going to be f of x. Your g prime of x is going to be e to the 2x. All right, so deriving x, you just get 1. Integrating e to the 2x. Remember, that's a u substitution of 2x being our u. So that means we're going to have a 1/2 out in front, e to the u. So it's 1/2 e to the 2x. Now, if you don't remember that, go ahead and do your u substitution over to the side, and then check to see that it is 1/2 e to the 2x. All right? So, what do I mean by evaluate each part with the numbers? Well, your first part is f of x, g of x. So if you're doing f of x, g of x, you're getting 1/2 x, e to the 2x. You have to evaluate that from 0 to 2 first. So you plug in your 2, 1/2 times 2, e to the 4th is just going to end up being e to the 4th. Minus 0, 1/2 times 0, e to the 0, well, that's just going to be 0. So this portion is e to the 4th. Okay? Now, the next part, you're going to evaluate from the integration from 0 to 2 of, and the next part we have, it is g of x, f prime of x. So g of x, f prime of x, so it's really just this, 1/2 e to the 2x. So when I integrate that, the 1/2 stays, and then I get another 1/2 e to the 2x. I already derived it once, I'm just deriving it again. So I get 1/4 e to the 2x. Now, notice that I'm just sort of leaving that negative alone. I'm going to remember that negative. I'm going to pull it down later, but I'm just going to deal with this right here with my 0 to 2. Okay? So I have 1/4 e to the 4th minus 1/4 e to the 0. Now remember, e to the 0 isn't nothing. E to the 0 is 1. So I end up with 1/4 e to the 4th minus 1/4. Okay? Now, I don't forget that I have this minus sign here. I also don't forget that I have this e to the 4th. So I have e to the 4th minus 1/4 e to the 4th plus 1/4. Okay? Now, as you know, if this were a free response, you could just leave that answer right there. What I want you to do is hit pause and see if you can make it equal this. 3 e to the 4th plus 1 over 4. Alright, so let's see what you did. So, in order to do this and to add or subtract any of these numbers, you need to have a common denominator. So this thing needs a 4 in the bottom, which means it needs a 4 in the top. So now you have 4 e to the 4th over 4 minus 1 e to the 4th over 4. Well, that's 3 e to the 4th over 4 plus 1/4. Well, again, you've got a common denominator. So you get 3 e to the 4th plus 1 over 4, which is what I told you to get in the first place. All right, so that is the end of today's notes, and it's actually the end of integration by parts. So I'll put the homework on, and then you can work through it, and then we'll go ahead and start integration by partial fractions, which is kind of fun as well. I do really like this chapter. All right, I hope everybody's staying healthy, and I hope everybody's good. Make sure to ask questions, and I'll talk to you later. All right, bye.